We will start this session now talking a bit on the change and how this change is managed towards EV. But of course, our heart is always beating for automotive, and therefore we are also very much focused on EV, what is happening in automotive industry. We heard this morning when it was started by Dr. Shin how important this is, and zero emission is only possible with EV, with battery electric vehicles, and let's have a look into this. Yeah, let us have a look why an EV is so important when we are looking into the left figure, and these are figures of Europe, unfortunately, but I think that is globally the same. All the greenhouse gas emissions break down by transportation, then you see that nearly 70% is coming directly out of transportation, and around 60% of the greenhouse gas emission is coming from cars. So it's clear that CO2 is detected as the major contributor, and as I also showed in my presentation before, the CO2 is directly responsible, and there are all companies globally, they have already set up targets. While we all are clear we need battery electric vehicles or the NEV the new electric vehicles on our streets, I think there are different purchasing criteria why people are buying or even not buying electrical vehicles. And I would say the green marked dots show the most important ones. At the end, what is driving is the range. How many kilometers, how long is the energy I can upload in this NEV, bring me how many kilometers. At the end, the overall price if I buy a BEV or NEV car, and of course, are there subventions? So are these cars anyway supported by the government? This might be very important purchasing criteria. Of course, also things like sustainability or just fun, because the acceleration over an EV is also nice. So why not also enjoying riding with new things? If we are looking into this NEV and the most important thing, the range where everyone is looking on, then we need, of course, to understand that this is directly related to the battery pack, to the density of the battery, and of course also the electronics and the engines, what are related to that. At the end, it's sometimes simple. Also, more batteries will extend the range, but also at costs and weight. And at the end, that can be also a compromise for dynamics. So the overall package is important. And when we are looking onto that, then it's also clear that a large car, so maybe a high-end car, can of course carry more batteries. It's more heavy, but can carry more batteries. So it's also a compromise. And we are looking into that in these tables here on the left side. Then you can see that this average vehicle price is directly, of course, also connected to this amount of batteries and the driving range. And when we are looking into the countries, the regions in the world, then we understand that especially China, where you also see a lot of electrical vehicles on the streets, they managed quite well, also the applicators there, to have models in all areas, from really cheaper segment until the premium cars like NIO. They have solutions for all. When we are talking on the range, then of course, what is most important, that we have also a charging network. We are talking on a sufficient charging network if we have like 5 to 10 charging stations per electrical vehicle. And if we are looking to that table, we can see that there are some areas already very well prepared, like China. Also, here we know already Korea is also well prepared. We will hear also the number. At the end, only this network of charging stations and also the availability of wall boxes maybe at home can help to stop this, what is called like range entity, because we might be all anxious that we running out of battery load and will just stand somewhere on the highway. And for that, of course, it's an ongoing task with the increasing amount of NEVs on the street, so that we have also a growing charging station network. That will be very important, despite the time of the charging, because we are all pampered from maybe like using 5 minutes for a stop at a fuel station. So I think that is acceptable, but if you need 1 hour for loading, that will be too much. As EVs are expensive, and we see here on the left the vehicle price as an example of Germany, but that is valid for all countries in the world. There is always the effort, or there are the efforts of the government to support that by setting the incentives. And we can see that clearly on the right. Whenever there is some incentive given, then the shares grow faster. Whenever the incentives are stopped, the shares are reducing and going down. So as long as they are so expensive, these NEVs, then of course there we will see an on-off strategy. So they are costlier, and this is what we need to, what the industry is trying to change. When we are looking into cost, then it's clear cost down is the most attractive, and for that, let's shortly have a look into the battery, into the NEV. On the left, you see the cost split down of NEV, and you see the most important piece of that, 25% is going into the battery cell. And if we are looking in the middle, about 50% of the battery cell is related to the cathode material. So if I start to think about cost down activities, then I need to start at the cathode material. And that was done in all the last years with quite some impact. And you are seeing that on the right. And nowadays, looking into this red line, that is the scenario which in the moment seems to pay out a lot in regards of cost saving, and is the strategy of mainly also the Chinese OEMs, and also Europe is now following to go for this LFP related cathode material, so lithium, iron-based phosphates. So seems that could be the way forward. If we are looking on the NEV market and this cost down activities we saw before, if you're looking to the table to the left, then we see that there's really a huge price war ongoing. Tesla is reducing its cost, was targeting to reduce the cost of 50% in the moment. GM announced they want to save $2 billion of USD. For operating cost of Volkswagen, even 10 billion, so BYD 10%, NIO 4,200 kind of cost cutting per car. So this price war, of course, is a part of this cost down overall to make these cars more affordable. Does that mean EV is getting this change to EV is getting into some different direction? No, of course not. When we are comparing the outlook of company IHS in January 2023, that is the line above, then we see what they made, which outlook they made. And if you compare that outlook to the outlook from July this year, then you see, of course, there is some slowdown overall. But at the end, in 2028, more or less, there will be no big difference. So this NEV is clear. The market is there. It will come. It will grow. In the moment, we see a smaller slowdown, but that does only mean that some full production scale-up is delayed. If we are looking into the global automotive market share as of today, We see here the automotive global production for all powertrain solutions in 2024 in million units. Then you see the market leaders like, you know them, Toyota, Volkswagen, Hyundai, and the main players. So I would say feels familiar. You see already here some specialities. These are like the BYD only offering or not offering ECI cars. So they started directly. Also like the end of the line, Tesla, 100% electric. So something is happening in the powertrain. If we are looking into this picture for only global NEV market share, then it looks quite different. Then you need to learn a lot of new names in this chart. Number one is then BYD, Tesla, of course, as one of the pioneers. Number two, then you find with Geely, another Chinese or somehow Chinese company there. We find Volkswagen, and then another with another Chinese. So this is a totally different perspective on that market, and that says this is really disruptive, what is happening in that market. Technology-wise, something new is coming, but also there are complete new players. So also the whole supply chain will be mixed up. There are also new players, old players need to rethink. So that is something what will influence and will need new orientation for many players. If we have a look on the Korean market, then we are also seeing it's a saturated market. So the development, of course, is not fast. But on the other hand, you also see there is also clear a big portion already in hybrid and in EV, and that will further grow. So that is the future. And when all these cost down and fueling, loading station, charging station topics are done, we can also expect that this will grow fast. See, plus 15% is the CAGR of the next 4 years to come. So that is quite interesting. If we are looking into the powertrain perspective for the Korean OEMs located here, then you see that Hyundai is already well placed with nearly 40% in alternative powertrain solution, and while GM, of course, is announcing and is planning to come up with solutions. KG Mobility already showing first models, and also Mitsubishi, Renault, Nissan showing full and mild hybrid solutions. So at the end, this change also is here, and it is not will not go back and will not slow down. So with this, we are coming to an end, and the message of this large overview slide, what also was shown already in the morning, at the end, we are in going a new way with the battery electric vehicles. We said supply chains are changing. There are new challenges in understanding technologies, in understanding surface finishing, protection, connection. So at least we heard about already some topics. We will hear later on also more solutions related to EV. Connectivity is a topic, wear resistance, fasteners. So message, we have all these. We have a lot of understanding on that. We have the experts. So whenever you are working on a project and you believe we could help there as best as earliest in your project, because very often surface finishing should be included from the beginning to enable some proper cost saving, some proper CO2 saving or improving of performance, then we would like to that you let us know. So we are there to support you, let us know, and the colleagues are here. Thank you.
I will share with you is about the new applications in the market. And I think as an industry, what we need to do is that there's a lot of changing happening in the market, in the industry. And for us, it's important that we know the trend and we know, okay, what's happening next and what could be the new application, new opportunity for us. And today, I think the main theme for my presentation is that I would like to introduce several new applications that we see in the market that will come later on, which may be interesting for all of us. So we just want to have a short introduction of this to everyone. I'm not going to repeat that. I think the main message here is that EV is growing, and there's a lot of new application in EV. And you can see in different country, different region, maybe the growth is different, but we see a clear trend that in coming few years, there will be more and more EV in the market. And I think everyone agree that most of the OEMs are investing their resources really going into this market. And we also see a lot of government pushing, really subsidizing this market. So for us, what does it mean? And we try to figure out for electric vehicle, what is the main difference? And one of the major difference is the battery. And you see here is a typical battery module in a EV. And we see there are different applications in battery. From the top, you can see cell management. We have heat sink, we have housing, connector, bus bar, different things. And then we have the real battery cell, which is having a lot of current collectors, which is copper or aluminum, and different surface finishing is needed. And housing, I think we'll discuss also about like different housing application. We have new finishes which needs better corrosion protection, and also maybe some fire retardant property is needed. And then you see battery junction box. We have different bus bar connecting the battery with the car, and then we have the signal. All this connection also needs surface finishing. And then fasteners. I think fastener is also one growing area. What we see is that there's a lot of fasteners in this battery housing that normally is made up of either steel or aluminum, and you need really different finishes for the fasteners to make sure that corrosion protection is there. And also we have zinc nickel and electros nickel application here. And finally, there's a battery management system. Again, he's saying IGBT, different things. We will introduce some of them today. Going to the battery. This is a typical lithium-ion battery cell, and you can see there are different applications. But I think the main theme here is that there's like connectors, but also the biggest surface area here is always the anode and also the cathode current collector, which is normally today is copper and also aluminum foils. And in a battery cell, I think we have a lot of different applications. I'm not going into details of everything because of the time limit, but I think let's go to, like for example, in the middle, you can see copper plating. This is mainly the current collector, and you can see there's a needs of high performance copper plating electrolyte. What does it mean? It means really high speed and low stress, but also high tensile strength. And the purpose is to really make a thin copper layer, the copper layer as thin as possible, so that we can really increase the energy density in a battery cell. And I think this is one example. And then we have another example, which is nickel plating. We have a lot of nickel plating application in the battery cell, like housing, like bus bar, and it can be electrolytic plating, it can be electroless nickel plating. So there's a lot of new application, and I just want to introduce to you that is really a new market for all of us. Come to a really real project example. This is one of the projects that we are working today. This is the we call it copper post-treatment for current collector. And the main thing here is that we are replacing Chrome 6 passivation with a Chrome 6 free passive post-treatment. So nowadays, I think the industry in the world, they're mainly still using Chromium 6 as a passivation for the copper layer. So it's acting as an anti-tarnish post-treatment, and the aim is to replace that with a Chrome 6 free process. And here I would like to share with you some data. So this is a normal test for a copper current collector, which is we call it heat treatment after the passivation. Normally it's 140 degrees for 30 minutes, and you can see the requirement is that there's no color change, and you can see in the picture here. And this is another test, which is the humidity test, and you can see after 10 days, 30 days, the copper layer is almost the same. And this is also a real battery cell test, and you can see after charging, discharging, and when we compare with the reference, you can see the behavior is almost the same as the reference, which is the normal Chrome 6 process. So conclusion, I think the conclusion is that I'm not going to repeat all this technical data, but I think important thing is that we see a lot of new application, new requirement in the market, and working with our customers or OEM tier 1s, we are able to deliver really the solution to the market, and this is a good example. Next one, I think this is an example of another current collector, which is aluminum. And normally there's a need here is the adhesion between the current collector and the electrode film. So the problem here is that after charging, discharging in the battery, the electrode or even the current collector is expanding and also contracting. And normally with all this contraction and heat, the adhesion could have some problem. So our solution is really to have a surface treatment which could enhance the adhesion of the surface. Yeah, I think the mechanism is that with our surface treatment, the surface of the aluminum is in a different structure that you can see all this anchor, and this will help improving adhesion. And you can see the SEM picture here. We have different processes like AC2, 5705, 377, different post-treatment processes for aluminum application, and according to the customer requirement, we can have different surface finishing. So this is a consolidated report together with our customers on this test of aluminum foil. And you can see that there's different tests that we've done. And you can see at the bottom, there's surface roughness, tensile strength, elongation percentage, surface energy of the foil after all this post-treatment. And I think I won't go into details again. All the tests are according to the battery application, and we can pass most of them. Comes to EMI shielding. There's another new application that we see in the market, which is in the battery. There's normally a control PCB, and at the moment there's always a steel box or an aluminum box with EMI shielding that cover this PCB. And what we see now is that there's trend because of the lightweighting purpose. The OEMs are moving to plastic box. The motivation of this move is really lightweighting, and with the plastic that we're using now is PA, which is an engineering plastic. And then we need to have pretreatment and also copper or nickel iron plating to provide the plastic with EMI shielding property. You can see we have a pretreatment process, especially for PA. And then also, of course, we have all this functional coating, which is copper plating, and also nickel iron plating, which is available for the EMI shielding property. Here you can see the EMI shielding test result, and it's all passing the requirement of the OEMs. And we have real projects which is really doing a lot of tests, showing positive results. I think that's the last new application that I would like to share with you. This is IGBT heat sink. So first of all, what is IGBT? I think this is in short, it is to convert the power from the battery from DC to AC. So this is a device to convert this current to the motor to give energy to the electric vehicles. And during the process, there's a lot of heat generated in the chips. So we need a cooling system, and there are different choices. One of them is air cool. The other one of them is liquid cool. And the industry today is preferring the liquid cooling system, which the air cooling system is working, but it's generating a lot more noise. And especially in the EV, noise is very important because the engine is gone. So the noise is coming from all these different components. So they want to reduce noise as much as possible. So the preferred choice at the market now is liquid cooling system. And with the liquid cooling system, the concern is always the corrosion protection. And I think the challenge here is that we need a good corrosion protection, but considering the shape or the geometry of the part is very complicated, we need a process which can have a very good uniform thickness distribution and a good corrosion protection. And with that, we have dedicated process, pretreatment, from pretreatment to electroless nickel to really offer this unique property. This is one example that we are working with an OEM. On the right-hand side, you can see the real picture of an IGBT heat sink. So it is selective plating. You can see the pad that need plating, and then we need to make it selective. We need to have a good pretreatment process. It is the substrate is aluminum, and after that we need copper and also nickel and also silver stripe. So I think I would like to summarize. I think I cover a lot of different applications today. A lot of them are new in the market, may not be have the biggest volume today, but those are the trend and new application that we see that is happening in the world, in China, in Europe, in Korea, in different regions and countries. And I think as an industry, we are developing new solution to all this new application because there are new challenges, different substrate, different requirement, different motivation, and we need to create or modify our supply chain to adapt to this new change. And hopefully, I think everyone in the room is getting something new. And if you have any questions, feel free to ask, and we are happy to share even more information with you. Thank you very much.
Let's talk about now corrosion protection excellence in EV applications. And Johnny already explained what all is happening in the EVs. And now let us also have a look what is in for the battery packages and for these applications. I think more or less we will look here into the battery housings and also the fasteners, and let's discuss what can we do there and how can we help. When we are comparing an internal combustion engine with an EV, battery electrical vehicle, what is most obvious? There will be redundant, or there are already redundant technical components, like the engine, like the cooling system, the engine cooling system, the front grills. The fuel system is not needed anymore. So a lot of things going out. And on the other hand, if you see on the right side of this slide, there are completely new technical components. We heard already from Johnny about the thermal management systems, but of course, all this charging the devices, what we need to have to make the battery system work. There are more electronics in this. We learned already before, but most obvious when looking to this scheme, then we see, of course, the battery pack is one thing which is directly falling into our eyes. Let us have a closer look into battery housings, which are today in EV mass production. There are several examples here, and they are showing there are really totally different strategies, normally from OEM to OEM, but of course also depending on the serial production, or depending on, is it a high-end model or is it one of the cheaper, smaller ones. And you see, for example, Volkswagen is using stacks of different aluminium for the housing. You see like Mercedes, steel and aluminium for upper and lower cover. We see also pure steel with Peugeot, and there's Polestar is setting on a mix also with steel and plastics, and also Nissan setting on steel. So this is depending really on the philosophy they are following on specific properties for the chassis stiffness and so on they need. Yeah, let us skip these slides and because they are leading a little bit far, and you had seen already this morning that there are many aluminium applications in the car. Of course, in EV we were talking on weight saving already today, so it's clear that there are also many strategies and many places where we can use aluminium. If we are looking and staying with our battery pack materials like we just saw, then you see there is always an upper housing and a lower housing, and they have also they are using different materials. And if you are seeing these figures here, then you see that for the upper we expect that also here the plastic portion will also further grow into the next years, also related to weight saving, but as well also, as you can put there, also some additional characteristics into like the fire protection and so on. And for the lower housing, you see a lot of aluminium and steel for the future. If we are looking into this a little bit deeper, then of course the battery pack housing is really carrying afterwards all these heavy battery modules, and this has a key role in safety, but of course also protection for the module on one hand, on the other hand also for everyone in the car. So also the strength and stiffness of the whole chassis is related to this, and of course also this all needs to be secured for electrical equipment housing to fulfill, for example, the IP67. That is a waterproof specification, in that case requiring half hour no problem within a depth of 1 meter. So in case there is an accident of a car, of course everyone wants to be also safe in that car. And there are these three main strategies we saw before, material selections, and you see here some of the details for aluminium that can be depending on the parts, like die casting, or it can also be extruded aluminium depending on the part. Steel housing has also a lot of advantages because that would enable always and also spot welding connection, which can also be cheap and is also established. And when you are going for mixed material, that enables also savings and also giving additional characteristics to that. And I think here the industry is by far not at the end in developing further. When we are looking in these solutions for what is in these battery housings for surface finishing, so where could we all start? When we are thinking in this aluminium direction, then of course for aluminium it's always important to have a very proper cleaning and surface preparation for the next steps in case there is additional corrosion protection needed, like a conversion coating on top, or if there is some additional paint afterwards. Then the main key is really the best preparation for adhesion to the E-coat or to the fire retardant is needed. For the steel, then very often is now zinc nickel in discussion. We discussed that already early this morning, that we need to have to avoid contact corrosion, especially when we are talking on these settings together with aluminium. And for that, zinc nickel is coming into the game to improve the corrosion protection. And also here, paint adhesion is also important because there are also paints afterwards. And as we said already, and Johnny mentioned that already in his presentation, there's also a need for fasteners. There is a need of different fasteners, and we will also come back to this later in the presentation, because combining different materials has always a huge risk for contact corrosion, and that requires then also the correct fastener plate. Let us have now a closer look into the finishes, and let's start with the steel battery housings. When we are looking into current mass production, there are different systems in place. That is always dedicated. What kind of car model do I have? What is behind? Is it a high-end model or is it the basic one? Then you can go from economic on the left, really just having the clean steel and a phosphate, and then the final E-coat, or really going then step by step with a full at the right side with a full zinc nickel finish with a passivation and a sealer on top before I go to the E-coat or the fire retardant. That would be the high-end, highest corrosion need. So at the end, this is also a decision what is the corrosion load of this specific car model, what are the engineers, which problems are the engineers facing, and what is the overall strategy of this model. If we are talking on electrolytic finishing, and here then maybe on the most at the far end one, then it's also clear when we are talking electrical vehicles, then this way is going to be really CO2 neutral in end of 2030, 39, depending on the OEM. And it's clear that, especially in that case, for my understanding, for our all understanding, also the electrolytic, the plating process should really be as CO2 friendly as possible. And therefore I believe, especially in that case, when there is a new line for these huge parts, because normally these housing parts are also large direct parts, then this is the right moment to think about membrane anodes. We discussed that this morning, so I don't want to go in depth there, but especially now, if there are new lines needed, new designs needed for these large parts, then membrane anode installation should be really thought over. I don't want to bother you too much, therefore only very shortly. You can do that with this closed loop, like I introduced to you this morning. Of course, you can also start in the easier way, only using the membrane anodes already. That will also help you already to save CO2. But on the other side, you are not able then to recover all the wastewater. But it's also attractive because it helps also to increase productivity dramatically. So that can also help if there is a line which is already close to the end of capacity and you need further capacity, then this can be also an idea. And as you know me already, of course, we also led that test externally to prove that it's really also working And here we can achieve around 30% CO2 saving. So can also be attractive, only think on membrane anodes. By the way, that is also patent protected, this system. And of course, we would like to introduce it to you. The next slide you have seen already this morning, so we don't want to bother you again, but keep that in mind, then also more is possible. Let us now have a look into the aluminium battery housings, because that's also a very important piece of that cake. In aluminium battery housings, we have also a lot of technologies, and as I said before, there the pre-treatment is really very important when you are looking into the waste. Normally it's like on the base material you are cleaning with one of our UniPrep materials, and you prepared for the conversion coating, which is then a part of the interlocks family. And then additionally afterwards also normally there is an E-coat or a powder coating on top to protect for high level corrosion performance. And also the aluminium is how can I say, has a lot of characteristics which you need to influence. When you are working on the cover, you need also to expect that with the surface finish, you are also designing the corrosion performance. You are influencing the paint adhesion. You are influencing how is the adhesive bonding afterwards. Also, how is the dielectric resistance at the end, and also the edge coverage is important in corrosion protection later on. If we are just looking into this upper box, at the end, all this is influencing the solutions, the aluminium solutions in the car. So for the battery modules, the cell covers, like the neutral salt spray test is often used, but fluid resistance is also important. And we learned already before from Johnny how strong or how difficult are also the characteristics for the cooling plates in the thermal management. So a lot of things to be considered. And to make crystal clear how important, for example, the paint pretreatment is, here's some negative examples. What might happen if the passivation is failing? Then you see on the left there are large scale aluminium corrosion defects. That can happen if, for example, the wrong process is selected, maybe just only a zirconium coating and not really an alloy coating, so where you should use maybe some interlocks. So that can have really dramatic influence. And if you see on the right, if the layer is not perfectly done, then it is really failing in the crosshatch test. That can happen if really the cleaning is maybe not properly, or the rinsing, or the coating too thick or too thin. So there are many effects, and I can imagine some of you who are working in that field know this very well. And this is really for me the most important, to start with the pre-treatment and to be really so focused on the details in that process. There are many options, and as I said before, with our UniPrep family and the alkaline and dismatter solutions and our interlocks, we have a full portfolio. But at the end, you need always to look into the details. So if you are working on this field and you really want to improve there, let's discuss with our specialists, get in contact and really look for your application, the capabilities of your line, of your setup, that we can find the really best fit to your requirements. And of course, the battery specifications, they are challenging, and of course, the processes are designed to really help to fulfill them. If we are looking finally into how to combine all these housings, and we shortly strived this fastener topic already before, then we are talking now a lot of assembly directly into aluminium, and that also asked for different fasteners. So these fasteners should be really self-forming fasteners, flow drilling fasteners, new ways of fastening, these also requiring different finishes, different friction. And we also see, especially coming from China, because there are already many electrical vehicles in the market, a lot of rivets used in these applications. And of course, that is also driving that. We are talking lightweight, so fasteners are getting smaller, and with smaller fasteners also it goes in parallel that they have higher hardness, which also increase the challenges for finishing them. So there is a lot of new things happening in fastening. It's not that there are less fasteners in an EV compared to an ICE, it's more that there are more specific fasteners, they are smaller, and there are also different, a little bit of different requirements. If we are talking fasteners, what are the new requirements? Just keep in mind there can be different coefficient of frictions because of different assembly, because we are now assembling all full automatic, so you need different friction. You may need different finishes. What is a key topic is technical cleanliness, because we are talking here batteries, so there should not be any contamination, which might have then a shortcut, indicate a shortcut, and contact corrosion. We discussed that already today. There are examples and you have the printout, therefore I don't go into the details, but of course there is now multiple mounting is requested, mounting in and out, different service intervals, so a lot of requirements for coefficient of friction now. We have solutions for all that. Also, really, if you need support there, investigation, please involve us and we can give some advice. Exactly, and I mentioned already technical cleanliness, and just to give you a feeling, for many specifications in that area for EV applications, they require, according to the VDA specification of the German Association, that there is class H, particle class H allowed, that is less particle size, no part bigger than 400 micron. That is not much if you are thinking you are producing in a bulk process in your production line. So it's challenging. You need to know what kind of process, and that is also influenced by the type of sealer you are using. Last but not least, we explained already today several times that there are advantages when we are mounting different materials together. If you are using zinc nickel, and of course, if you are looking into potential difference here from aluminium, and you see here nickel with a high zinc nickel with a high nickel incorporation, 12 to 15%, then you see this is the smallest difference, and the smaller the potential difference, the lower will be the flowing corrosion current. And this is what you can see also now. We did a test and we mounted aluminium panels with fasteners with zinc plated and zinc nickel plated, and just a blind reference with a plastic screw. And we will see on the next slide what is the outcome. Yeah, and if you are looking on this more or less last slide of this presentation, then you see on the left is the performance against zinc and aluminium, and you see there is really contact corrosion, so it's not acceptable. The blind reference in the middle, no, there is just corrosion, but no contact corrosion, so no pitting, and it's still stable, and with the zinc nickel that is working. And this is why we are seeing also much more zinc nickel now with the EVs coming. Also with zinc nickel, you are also on the fasteners, you can also fulfill the small sizes like M3, M4 is also possible with zinc nickel, and therefore we are seeing this a lot in the market. With this, let us come to the summary. Short summary, I think we could show you that there are many solutions and many things to be considered related to battery housings, and of course all what is valid for housing is also valid for other applications. The processes are available. Of course, the devil is always in the detail, so let us think on customized solutions for your applications or for your projects. If you are working with a tier or an OEM, we are absolutely open to support and bring our know-how in, and we are always very open to learn. Maybe something new is coming up, and we would really love to work with you together. Thank you for listening, and thank you for your time.